Hello and welcome again. Good to know you're there. Thank you for being supportive. You helped sharing the videos and you subscribed, you're following, you're liking. Thank you so much for all this. Now, if you have questions, please don't hesitate to make them known. If you have a contribution, please also put in the comment section. If you feel a question was solved and it was not properly done, of course, no human being is perfect. Please also make it known. Thank you so much for being supportive. Thank you for liking, for sharing. And if you've not liked, please do. If you've not subscribed, please do, so you get rich content like this, both for you, for your colleagues, and your children, or perhaps your younger one. Thank you so much. Thank you. So what we're having on while we still saw Surds is division of Surds, rationalizing of denominators. Now, what we'll talk about division, of course, we just the previous video you want to go back. We looked at multiplication of Surds essentially, but now we're beginning to have numbers where one divides the other. A number is divided by another. So when you have something like this, what do you call it? You call it fraction. A fraction. So this is what you have as a fraction. Now in some cases you will have the fraction in which case a surd is included in the fraction. It could be like a square or something like this, or maybe this, or maybe the square root of b. Now, in this case, we'll be looking at this particular where we are dividing fractions that have rationalizing fractions that have surds in the denominator. Now, first of all, let's ask ourselves, why do we do this? We are doing this. Now, why do we do this? Okay, let us put down fractions. Let's just put down this and then the other. Now, why do we do this? Why do we rationalize denominators? We rationalize denominators in order to make them turn the denominator to a rational number. We rationalize denominators in order to make them rational numbers. So what are rational numbers? Rational numbers are essentially, or put it simply, whole numbers. Whole numbers. So how do you make a denominator a whole number? Very simple. By multiplying that denominator by the surd that have made it irrational. But then don't stop there. Whatever you do to the denominator, you do to the numerator. Now please remember, in your lower levels, you know that a fraction is made of both the numerator, which is the part of the fraction above, and then the denominator. So if you ever have the denominator to be in a surd form, or to have a surd included in it, so the best thing to do is to rationalize the denominator. If you have something like, you have something like this, or the square root of a divided the square root of b. The best thing to do is to rationalize the denominator. And how do you rationalize the denominator? Like I said, it is to what? Multiply both the numerator and the denominator by the surd that have made the denominator that have made the denominator irrational. So in other words, rationalizing means to make rational, and to make rational means to turn the denominator to a whole number. So I already have examples here, so let's take a look at them one by one. Now let's come over to this place. Let's use here. Here we have the first example, solutions. Okay, the first one, we have 7 all over the square root of 8. In order to not rationalize this, what we'll do is to do the next step. The next step will be 7. We said to rationalize the denominator is to multiply the entire fraction by the surd that have made the denominator irrational. So have it like this, 8. And now we'll now multiply it by, because it's by this 8. Now, by doing this, what will happen is you're going to have 7 times root 8 all over root 8 times root 8. Okay? If I want to go here, like if you check the previous videos, this will mean 7 root 8. Of course, you know you can extend this to make it what? Root 8 times root 8. Root 8 times 8. And 8 times 8 is what? 64. I'll take all the steps gradually, don't worry. So this is what, because it's still the same, so you can join the two. So it's going to be 7 root 8 all over what? The square root of 64. Sorry, right? Because 8 times 8 is 64, right? Good, so what does it mean? So 7 times root 8 or 7 root 8 all over what? What's the square root of 64? Is 8. Now, what could have happened? I already know it here. When you start jumping steps in maths, you can do it without just about 2-3 steps, you know, but I've just gone through this for those who may not understand. So what was done was actually to join these two, make it 8 times 8, the square root of 8 times 8, and 8 times 8 multiplied gives you 64. Then, in this place, the square root of 64 is what? 8. So what you have here is going to be 7 times root 8. So this is just what you have. 7 root 8 over 8. You've seen this now. So that's just what you'd have. There are different ways of writing it. You can write that 7 over 8 root 8. 7 over 8 root 8. The same thing. So that's just 7 over 8 root 8. So let's pick the second one. The second one. We have the time. 2 is going to be, second is going to be 5 all over root 5. The same thing, if we do it, this is going to be the same thing as 5 over root 5. Because we want to make the denominator a rational number, the rule states that we multiply the denominator by the surd that makes it irrational. And it turns out to be that it is only the irrational surd that is the denominator. So we just multiply by this. So it's going to be 5 root 5 all over root 5. But please note something. In maths, actually, root 5 over root 5 is actually 1. Because they are the same thing. This cancel this. Here 1, here 1. 1 divided by 1 is still 1. Including here 2. 8, 8. What give us what? 1. That is essentially. But let's go essentially. In other words, this expression is still the same thing as this. That's what it means. So let's go 5 times. This will give us what? 5 times root 5 all over 5 times 5 root 5 times root 5, which is still the same thing as writing. The code of them are the same. If you like, join it together. If you don't want to jump now, so if you know it already, you can just go back. You know, root 5 times root 5 is just 5. But for the benefit of those who do not know it, you just follow gradually. 5 times root 5 will be 5 times root 5. So this is going to be square root of 25, because 5 times 5 is what? Or let me just bring it together. We don't jump the step. 5 times 5. So 5 times 5 is what? Let's go. 5 times root 5. 5 times 5 is square root of what? 25. So what is the square root of 25? It's going to be 5 times root 5 Square root of 25 is 5. Square root of 25 is what? 5. Right? Yes. Because the square root of a number is a number that when multiplied by itself will give you the number that you square rooted already. So it is 5 that you multiply by itself to give you 25. So that's how this should be. So work can divide. The same thing here. 5 is common here. 5 here 1, 5 here 1. So 5 and 5 here divide. So what remains? It remains 1 times root 5 is root 5. Root 5 all over 1. Right? Root 5 divided by 1 is what? Root 5. Take the final answer. In other words, this is the same thing as this. So that's your solution. So this is how we rationalize this number to get this. So thank you so much for watching. Now try your hands on this and this. In the next, we're going to see. Thank you so much. Bye for now.